incredibly vast. Naturally, humans always wanted a glimpse beyond its limits. To answer the question of what is beyond our universe, we must first understand what the universe is. Today, we'll learn about the structure and size of the universe and try to take a look into the unknown. We'll start our journey with the solar system, where we will get a chance to marvel at rare photographs taken by spacecraft. After that, we must leave our star system to see what secrets are kept by the neighboring system Alpha Centauri. Wandering around space, we'll come across black holes that can not only consume everything in their way, but also create entire new star systems. We will end our journey beyond the bounds of our universe, where we will encounter an identical copy of yourself. Welcome to space. Let's start with our own solar system. Today you'll find out what temperature it is on the sun, when there's an ocean aside from Earth, and which planet has golden clouds. Our solar system consists of the sun, a yellow dwarf, and 8 planets spinning around it. Of course, there's also satellites, 5 dwarf planets, asteroids, comets, and even space dust. Our galaxy is colossal in size, and it has hundreds of billions of planets and stars. But scientists have insisted for a long time that the solar system is unique. Many scientists speak of how atypical it is and study the peculiarities of our planetary system. The Sun is our shining star located in the middle of our system. It's very unusual, so scientists have been studying it for many years. Our star is 85% brighter than other stars in our galaxy, with temperatures on its surface reaching 5,700 degrees centigrade or 10,300 degrees Fahrenheit. And here's something curious about the Sun. Logically, the temperature should rise as it gets closer to the surface, but the Sun doesn't follow that rule. The hottest part of the Sun is the core, reaching around 27 million degrees Fahrenheit. That's what's been racking the brains of many scientists and professors. Thanks to this Thanks to this photo, we can see the upper atmosphere of the Sun, the corona, and on its surface you'll notice black filaments coming off the surface. This is known as solar prominence. It looks like filaments and clumps of plasma of various shapes, which eject huge amounts of coronal gas into the space and create space weather storms. But with them too, things aren't so clear-cut. Sometimes these prominences break off from the surface of the star and can disable Earth's satellites and even kill the crew of the ISS. They also is a joy to hear. And now let's talk about the planets. Mercury is the first planet in the solar system, located approximately 36 million miles from the Sun. It is the smallest planet in the solar system, only slightly larger than the Moon. Due to being the closest to the Sun, its surface reaches 800 degrees Fahrenheit during the day to negative 310 degrees Fahrenheit at night. The first picture of Mercury was captured by the automated Messenger spacecraft in 2008. It was the first spacecraft to fly past Mercury, and it continued until 2015 when it ran out of fuel and crash-landed on the planet's surface. In a video made from thousands of images of Mercury, you can see rays emanating from a northern impact. They stretch over almost the entire surface of the planet. In general, the inner world of Mercury is similar to the Moon since it's covered with craters. And in this last video,
like Roblox, the sandbox allows you to build your own 3D games using its Game Maker application. Unlike Roblox, the sandbox is entirely decentralized, meaning no one company or group.
In this last video, you can enjoy the sight of a small planet passing by a huge star. It's truly mesmerizing. Let's move on to the next planet. Venus, just as fascinating. This is the second planet in the solar system, located at a distance of 67 million miles from the Sun. Venus is often called the Earth's twin because it's similar to our planet in mass and size, but that's where the similarities end. By the way, Venus also happens to be the closest neighbor to our planet. It was the first planet to be explored by spacecraft. The first time the surface was scanned was in 1962. Magellan then made a map of the planet's surface using radar technology. But the most successful image of Venus was taken by the Soviet robotic module Venera 14. It stayed on the rocky surface of Venus for an hour and then succumbed to the atmospheric pressure of the planet, which is 90 times higher than the pressure on our planet. In the photo, we see a rocky desert, yellowish clouds of sulfuric acid that maintain the heat on the planet and smell like rotten eggs. This photo was taken 40 years ago, but the digital processing and merging of unusual images of Venus continues to this day. And the changes suggest that there are active volcanoes on Venus. Now we'll leave the twin planet behind and move on to Earth, the planet with life. The distance between the Earth and the Sun is 93 million miles. Now you're seeing the most famous photograph called the Earthrise. It was taken from our natural satellite, the Moon, but we'll get back to that. The photo shows the Earth rising above the horizon of the Moon. This image was taken by the crew of Apollo 8 and was originally in black and white, but with the help of modern digital technology, it was possible to add color to it. 2 years earlier, another black and white image of the Earth was taken by the robotic spacecraft Lunar Orbiter 1. This video shows footage from the International Space Station recorded in 2017. This video was taken at night. We can clearly see the northern lights moving across the sky. It starts over North America and moves towards the Gulf of Mexico and the coast of Florida. Then we can see the nighttime beauty of the cities in Europe and the Mediterranean Sea, where clouds are visible with flashes of lightning and thunderstorms. As I mentioned before, our planet has a satellite, the Moon. Its size is about 1/4 of the Earth for a satellite. The Moon's gravity affects the tides on Earth. The Moon's rotation around the Earth's orbit and its own axis are synchronized, which is why the same side of the Moon always faces the Earth. In this photo, you can see the captain of Apollo 16 crew, John Young. He's waving to us. You can also see the lunar car, which set the record for the fastest movement on the Moon at 11 miles per hour. Mars was a god of war. Did you know that all of the planets in the solar system are named after ancient deities? The only exception is Earth. Mars is 140 million miles from the Sun. Up until recently, many believed that there's life on this planet, but so far, we've found nothing. Right now, the Perseverance rover is on Mars, which recently sent images from the surface of the planet. A close-up photo shows the Martian soil made of rock and red sand. Mars is considered the most suitable planet for exploration, and perhaps in the near future, we may see the colonization of a new planet. The weather conditions there are relatively acceptable unless, of course, you consider the lack of oxygen and dust storms that can go on for months. In another photo, you can see the highest mountain in the solar system, Mount Olympus, reaching over 16 miles in height. This is 3 times taller than Everest, the highest mountain on Earth. The picture was taken by Chinese spacecraft Tianwen-1 in 2021. Among the images taken from orbit were the first photographs of the planet's south pole, where almost all of the planet's water resources were localized. Right now, scientists are exploring Mars in full. They regularly receive images from the red planet, which helps them study all the different features of the planet.
अभी गार्नियर कलर नेचुरल्स खरीदें और पाएं गोल्ड जीतने का चांस।
आपका रूहानी सफर लम्हात की दूरी पर है। अपना वीजा नुसुक की वेबसाइट के जरिए बआसानी हासिल।
Next in line, we have Jupiter, a gas giant located 485 million miles from the Sun. This planet has the largest mass compared to the other planets. The picture you see now was taken from Voyager 1 spacecraft in 1979. You're probably wondering what the Great Red Spot is. It's a huge storm system raging on Jupiter, several times larger than our own Earth. You can also see another spot at the lower left, and that's the Europa satellite. This image confirms that there is an underground ocean on this moon. Another spot in the top right is the satellite Io. This moon has so much volcanic activity that no impact craters could be found. In the other photo, you can see all of Jupiter's moons as well as the ring, which was only a hypothesis until 2003. NASA's Galileo spacecraft confirmed the ring was formed due to a collision of meteorites with nearby satellites. This image was taken in infrared range by the James Webb Telescope. It was the famous JWST that was finally able to show us this ring. In total, Jupiter has 4 main satellites: Io, Europa, Ganymede, and Callisto. The first satellite, Io, can be classified as one of the most unusual moons of the entire solar system. Volcanic activity on Io is the greatest discovery of the space age. Voyager 1 observed 9 active volcanoes, and more eruptions occurred between the visits of Voyager 1 and Voyager 2. The height of these eruptions above the surface is over 185 miles, with a velocity of 1.6 miles per second. This photo shows the volcanic eruption consisting of sulfur and sulfur dioxide. The second satellite of Jupiter is Europa. In my opinion, this is the most interesting moon because under the layer of ice there is likely an ocean many times larger than any ocean on Earth. And in theory, life could have been formed there over a long period of time. Ganymede is the largest moon in our solar system, even larger than Mercury or the dwarf planet Pluto. Ganymede is the only moon known to have its own magnetic field, something that's usually only found on planets like Earth. The magnetic field causes aurora lights, or glowing bright ribbons of gas that surround the satellite's poles. Imagery taken by NASA's Juno spacecraft on June 7, 2021, provided new insights into Ganymede's surface features, including craters, prominent dark and light terrain, and long structural features possibly related to tectonic breaks. The last is Callisto. This picture was taken in the 1990s by the Galileo spacecraft. It shows many craters. You can also see bright white spots standing out in darker areas. This is most likely ice. These pictures are truly mesmerizing, and in the future, we'll keep getting more and more of these images. Next, we move on to the least studied planet, Saturn. It's believed to be completely composed of different gases which are compressed into metal closer to the core. The funny thing is, this gas giant could float on the surface of the water because it has a very low density, lower than the density of water. Saturn is 915 million miles away from the Sun. This image was taken in 2005 by the robotic spacecraft Cassini. Cassini was one of the most ambitious projects in the field of planetary pictures. Here's Saturn's majestic rings appearing only as a curved line, partly brown due to its infrared glow. The best way to see the complex structure of the rings is in the dark shadows they cast at the surface of the planet. Saturn's northern hemisphere can appear partially blue for the same reason that Earth's skies can appear blue. The molecules in the cloudless parts of both planets' atmospheres scatter blue light better than red light. But we don't yet know why some of the clouds are colored gold. This picture was also taken by Cassini, but now it shows 2 satellites of the planet, Cepheus and Mimas, which are visible from both sides of the rings. At the top of Saturn, you can see dark shadows cast by wide rings, which demonstrate their exceptional complexity. In the UV light, the image highlights the texture of the background, the clouds of Saturn. Unfortunately, in 2017, the Cassini spacecraft was given the command to dive into Saturn. The main thing that sets Saturn apart is the striking system of 7 rings. They're made up of billions of ice fragments that perfectly reflect light and therefore are clearly visible. The total radius of all the rings is huge, 45,000 miles, and the thickness or height is only 1.6 miles. It is believed that these rings are fragments of a former satellite destroyed by the planet's gravity. Uranus is a blue Uranus is a blue planet located 1.8 billion miles from the Sun. The only spacecraft that's been able to approach Uranus was Voyager 2. As I already mentioned, the color of Uranus is blue, or to be more precise, it's blue with a hint of green. The planet gets its color due to methane. The core of this planet is made of ice, and the temperature at the surface is minus 371 degrees Fahrenheit. The wind speeds on Uranus reach 560 miles per hour. That's how Uranus got the nickname Ice Giant. By the way, Uranus is the only planet in the solar system that rotates on its side. The Voyager took 2 pictures, one more realistic to the human eye and the other using artificial colors and contrast enhancement. Not much is known about Uranus. According to the images, it has similar rings to Saturn but less bright, and it's surrounded by 23 satellites completely covered in ice. In the future, Uranus may become the main focus of NASA. They want to send a new spacecraft to this planet to study the surface. The last planet in our solar system is Neptune, located 2.8 billion miles from the Sun. It cannot be seen from the Earth with the naked eye. The camera of the Voyager 2 spacecraft captured Neptune and Triton together in the crescent phase. An elegant photograph of the icy giant planet and its overcast moon was taken looking back just after the closest approach in 1989. Also, because of the angle this picture was taken at, Neptune has lost its usual blue hue. Neptune is smaller than its brother Uranus, but its mass is greater. The second image distinctly shows light feathery clouds floating high in the planet's atmosphere. Most of the planet is made up of invisible hydrogen and helium. This planet has the strongest winds in the solar system, reaching speeds of 1,240 miles per hour. So walking To start with, let's get a better understanding of how far our closest neighbor is. And to gauge this, we can use the fastest space apparatus invented by humans, Helios 2, a satellite system dedicated to sun observation. Its speed is 157,000 miles per hour, which is about 0.023% of the speed of light. Rather impressive. The resources for colonization of the new world are packed, just waiting for the signal to launch. We're heading to the Alpha Centauri system. 3, 2, 1. Don't worry, there's nothing wrong with your internet connection. The picture really stays the same. Right now, we're moving faster than anything ever created by humans, but on the cosmic scale, we're practically standing still. We'll be able to reach the nearest star system only in about 18,000 years. That's the reality of things. Only when you realize the scale of these things can you understand how important it is to study our cosmic surroundings if we ever stand the chance to wake up and enjoy the sunshine from a different sun. The costs are too great to do this at random. That's why Alpha Centauri became one of the first star systems to be studied so closely. People noticed the main star, or more precisely a pair of stars, Alpha Centauri A and Alpha Centauri B. Both stars are sun-like yellow dwarf stars, which appear as a single star to the naked eye. The third brightest star in the night sky captivated the scientists' attention since prehistoric times, including the Summer Civilization and the ancient Egyptians. It's even mentioned in the words of Ptolemy, but the systematic scientific study of the star system only started in 1915 when the British astronomer Robert Innes discovered the third star in Alpha Centauri, a red dwarf that was given the name Proxima Centauri. To this day, it remains the closest known star to the Sun. The open and detailed study of our nearest star happened at the same time as the start of the golden age of science fiction and space opera, which leads to a huge rise in popularity for Alpha Centauri. It has been and continues to appear in the works of sci-fi writers, artists, movie directors, and even music composers. The proximity of another star stirred the minds of creative people, from the Strugatsky brothers to James Cameron, because there in the different world under a different sun could reside and develop entirely new civilizations. And so Alpha Centauri forever earned its spot in people's mind as the place with the most potential of extraterrestrial life. However, the reality is much grimmer, as it often happens. The active study of exoplanets planted a new seed of hope, discovering a signal, or at least circumstantial evidence of life on faraway planets. Scientists found 2 planets in the habitable zone in the Alpha Centauri system, Centauri AB and Centauri BB. However, unfortunately, after a more detailed study, both planets turned out not to be habitable as we know it, and so astronomically speaking, these planets were temporarily shut down. But everything radically changed in 2016. After years of intensive search, the scientists managed to find and, more importantly, confirm the existence of an exoplanet in the Alpha Centauri system. What's more, this exoplanet rotates around our closest neighbor, Proxima Centauri. As such, the find was named Proxima Centauri b. The planet is approximately 4.22 light-years away, and it's incredible that it was discovered in the first place, because the planet's mass is only 1.1 times of the Earth's mass. It was a very lengthy and work-intensive process to confirm this existence, which was done by measuring the radial velocity of the planet as it passed across the disk of its parent star, Proxima. But the surprises don't end there. Proxima Centauri b had more surprises in store for researchers.
चलो रखता हूँ, सुबह से कुछ भी नहीं खाया, अभी टाइम मिला है।
बिजली की बिल की डेट निकल गई।
हाँ पता है मुझे, इस वक्त
In April and May of 2019, Parkes Observatory in Australia recorded strange radio signals over the course of 30 hours, potentially coming from the Proxima Centauri b at the frequency of 982,002 megahertz. How did the scientists conclude that? Answering this would take us another half an hour, so we'll quote the official statement. The shift in the frequency of the signal matched the orbital movement of Proxima Centauri b, and afterwards, the signal mysteriously vanished. The second attempt to establish connection in 2020 was unsuccessful, and in 2021 it was calculated that the probability of a species being both present in the nearest star system and able to produce radio communication was 10 to the minus 8, which means the likelihood of this signal being artificially created was extremely low. Additionally, since 2017, the astronomers closely watched for any activity around Proxima Centauri using radio telescope Atacama Large Millimeter Array. The red dwarf exhibits extraordinary activity, making coronal ejections, these so-called flares. The brightness of one of these flares increased 1,000-fold over 10 seconds, occurring over 2 minutes overall. Unfortunately, this fact signifies that Proxima Centauri b would be exposed to such a large dose of radiation that any life form would cease to exist. Considering that such flares are not uncommon for Proxima, the scientists theorize that any atmosphere that may have existed was destroyed and dispersed into space. And the last argument against Proxima b being habitable is the fact that the planet's cycle around its sun is only 5.12 Earth days. Sadly, this means the planet is too close to the star to be hospitable to life form as we know it. Even a cold star classified as red dwarf radiates too much heat to sustain water in its liquid form on the surface of the exoplanet. But the discoveries surrounding Proxima don't end there. Using the espresso spectrograph mounted on the VLT, the European Southern Observatory's Very Large Telescope, from 2020 to 2022, the scientists studied the transit of a mysterious, very small object which is estimated to be smaller than Earth. Eventually, a planet that came to be known as Proxima d was discovered using the method of measuring radial velocity. It's one of the most promising mini-Earths to be studied in the near future. The radius of the planet is estimated to be 0.8 of the Earth's radius, while its mass is twice as heavy as the mass of Mars. Scientists have yet to determine the viability of Proxima d as a habitable planet. But if the planet is uninhabitable, what use is that conclusion here on Earth? You've got to look at it from a wider perspective, taking the future into consideration. This discovery shows that our nearest neighboring star system is filled with interesting new worlds, accessible for further research and in-depth study. And even if the recently discovered world is not suitable for living, its very existence suggests there are plenty of other exoplanets beyond the current scope of what we can see. What do we mean when we talk about the current scope of discovery? As of today, we only have two main methods of searching for such exoplanets. The most commonly used is the transit method, whereupon the telescope observes the stars for extended periods of time to detect small but regular changes in their brightness. These changes signify that a planet moves along an orbit between us, the observers, and the star. The other more complex method is known as the Doppler spectroscopy, also known as radial velocity method or the wobble method. When two large celestial objects, such as a star and a planet, are interconnected by gravity, it doesn't look like one object spinning around another like a ball on a string. Instead, they both rotate around a mutual center of mass, also known as a barycenter. For example, the barycenter of the solar system is located just beyond the surface of the Sun. It makes the Sun to wobble in place, which in turn affects the amount of light that reaches our planet, an effect known as the Doppler shift. As the star gets further from us, the length of the light wave is increased, and as it's moving towards the observer, the length decreases. The astronomers can search for the regular Doppler shift occurrences to conclude the existence or absence of an exoplanet. These methods are fairly effective when we search for large exoplanets. A large celestial body blocks more starlight or causes a larger wobble. But discovering objects such as Proxima Centauri b is much more difficult. These numbers speak for themselves. As of today, only 36 planets out of 32,073 registered in the NASA Exoplanet Archive have a smaller mass than Earth. We only see the giants, which are usually less habitable than the compact mini-Earths. So, what needs to change in the near future? The astronomy scientists have an assured answer: James Webb, the brand new space telescope, the launch of which was observed by the entire scientific community as well as anyone who cares about astronomy. It has the potential to revolutionize our understanding not only of astronomy, but the way the world works as a whole. As well as detecting and studying the light from the very first galaxies, one of the most important tasks faced by the telescope crew is the search for habitable exoplanets. The image captured by James Webb should be so detailed that we'll be able to detect the presence or absence of atmosphere on Proxima Centauri b, because if the planet has an atmosphere, its winds will redistribute the heat to the cool side of the planet. As such, it will be possible to measure how much heat the planet radiates in an infrared range. As the planet moves along its orbit, we will mostly have the view of its cool side, depending on the way it's positioned. If the planet has an atmosphere, the heat will be distributed more evenly, and there'll be less fluctuation of heat along the orbit. On the other hand, if the planet doesn't have an atmosphere, then the heat exuded in our direction will fluctuate dramatically as the planet moves. In other words, for the first time in astronomy history, we have a chance to directly observe the planets beyond the solar system. This opens a whole world of opportunities. We'll be able to not only detect the existence of an atmosphere, but its exact components. For example, the presence of ozone, because it would absorb some of the frequencies of infrared light waves, leaving distinct gaps or lines in the spectrum. James Webb can record these. Let's say that a hypothetical alien civilization observing Earth discovers distinct ozone lines in the Earth spectrum, which would enable them to conclude we have an ozone layer, and subsequently, oxygen, which makes life possible. We could make the same conclusion.
एक कप और है कितनों का बहाना है एक कप और तुम है एक और कप चाय
Furthermore, James Webb can determine the axial tilt of a planet, as well as its size relative to the size of the star. All of these are very important parameters, which we'll learn to apply in the future when the Space Telescope fully begins its mission in Lagrange point L2 in the summer of 2022. And in the meantime, the telescope is being calibrated and prepared for the initial observation before uncovering the deepest secrets of our universe. When we talk about JWST, we're talking about the imminent future of studying exoplanets. But what if we look a little bit further? What awaits us in a more distant but already foreseeable future? Travel to these new worlds? Of course. Only in sci-fi spaceships as they move through space using hyperspace engines and warp drives. Breakthrough Starshot is an innovative project aimed at creating spaceships with a light sail, capable of reaching the Alpha Centauri system in 20 to 30 years by reaching the speed equal to 15 or 20% of the speed of light, thanks to super powerful lasers. This initiative attracted the attention of many space enthusiasts, including the founder of Facebook, Mark Zuckerberg. This project involves several stages, the first one of which is taking the base ship to the orbit, which will then get a number of smaller space equipment to orbit. The second stage is the most challenging, creating an entire forest of super powerful lasers located around the world to enable the constant acceleration of the equipment due to the Earth's rotation. Each piece of equipment 4 by 4 meters in size would be targeted by several lasers as powerful as 1 terawatt hour. That's quite a lot, considering that the mining of all existing cryptocurrency takes 121 terawatt hours every year. Altogether, the project founders, Yuri Milner and the late Stephen Hawking, planned to send 1,000 items of equipment to Alpha Centauri. And even then, the estimated cost of the project is suspiciously optimistic, only $5 to $10 billion. Considering the creation of James Webb taking $10 billion, the value of these projects to science is certainly comparable, if not the same. Just imagine, If we could send the probes to the stars that could become the penultimate stage in preparation for colonizing the faraway worlds, this would allow humanity to receive sufficient information about the worlds we may plan to visit in the near future. It could also answer that most existential question: how many worlds are there, and how likely is the existence of life out there? Life as we know it. Not to mention the more exotic options like those science fiction authors love to invent. Finally, we want to discuss the potential non-standard life forms we might encounter on an exoplanet. Remember how mid-video we mentioned that Proxima Centauri is a rather temperamental star which flares up every 10 to 30 hours, showering the exoplanet Proxima b with abrasive rays, incredible amounts of radiation, and other treats? Well, these conditions are deadly to practically any life form on Earth. But the hope to encounter aliens lives on. Theoretically, life on Proxima Centauri b is possible, even taking into account the massive burst of radiation. Some living beings are able to hide from the deadly UV radiation. Aliens, or at least their single-cell forms, may exist under the planet's surface or deep in the water, taking cover in natural hiding spaces. Additionally, the process of UV absorption by proteins that's not been fully studied yet, which once again, in theory, allows us to speculate that organisms that possess these protective proteins can convert the UV radiation into biofluorescent radiation with a different wave frequency. Roughly speaking, we could dig down a few feet below the surface of Proxima b and discover an entire civilization of glowing biofluorescent creatures. Let's take Earth as an example. As you come down to the bottom of the ocean, you discover that some types of coral polyps contain fluorescent proteins, which are photoactivated when exposed to UV radiation in the long wave A range at wavelengths of 315 to 40 nanometers, and in the blue regions of the spectrum at 420 to 700 nanometers, covering it into radiation with a longer wavelength. If there are organisms on Proxima b that could have adapted this method of radiation conversion, this planet could glow very brightly at certain wavelengths, possibly even within the visible spectrum. And such powerful glow would be possible to detect using the incredible tech such as James Webb. The possibilities presented by studying exoplanets are hard to overestimate because we're not just nearing the answer to one of the greatest questions in history. Are we alone in this universe? It also allows us to expand our horizons of development and distribution of humanity across the universe. Time will tell if Proxima Centauri b is only the first of a trillion similar worlds, or if it's an exception. While we are alone in the universe, it's up to us to answer these questions, and our only allies in conquering space are human perseverance and curiosity.
The first company I started was PZRAM Technologies. The purpose of the company was to establish
It would be difficult to find a person who had a deep and serious thought about the scale of outer space and our universe and didn't feel the utter chilling to the bone terror. Endless empty space, terrifying black holes, able to practically erase matter, and trillions of strange worlds, exoplanets that are so distant and mysterious that they seem unattainable. Today we'll tell you about 6 incredible exoplanets with conditions that resemble real hell, just floating through space entirely isolated, and some even fooling astronomers. First is Coret 7b. First on the list is an exoplanet with a very exotic precipitation. And no umbrella will help you unless it's made from titanium. Meet Corot 7b, a planet where it constantly rains rocks. The size of this unusual planet is just over 1.5 times the size of Earth, and its age is about 1.5 billion years. It's relatively close by, only 489 light years from us. Back in 2019, when Corot B was first discovered, the scientists considered it the first rocky exoplanet that resembles Earth. However, we class it as uninhabitable with 0% probability of life on the planet. If you're ever lucky enough to watch the sunrise on this planet, this sunrise would be the last thing that ever happens to you. The rays of the morning star Corot 7 from the Monoceros or Unicorn constellation will turn you into ash as soon as the sun appears over the horizon. The reason sunrise on this planet is so much brighter is due to the fact Corot 7b is 60 times closer to its star than we are to our sun. In essence, the visible size of the Corot 7 star is 360 times larger than the way we see the sun. The temperature on the sunny side of the planet can reach 4,700 degrees Fahrenheit or 2,600 degrees centigrade, which makes the surface hot enough to melt and vaporize rocks. Next, something incredible happens. Hot, vaporized rock rises to the upper atmosphere, where condensation happens, turning the vapors into fine gravel during the colder front passing, which leads to the small rock fragments falling to the ground, better known as the literal rock rain. Looking deeper into it, some theoretical models suggest you can come across the entire ocean of lava on this planet. The situation is made even more dire due to the fact the planet is locked in this position, with the fire and sulfur side always facing the host star. At the same time, the other side of the planet is very cold, with surface temperatures reaching as low as negative 390 degrees Fahrenheit or negative 235 degrees centigrade. Astronomers think that Corot 7b formed initially as a gas giant, which was 100 times larger than Earth, but as it moved closer to its star, the gas membrane was getting thinner under the influence of the sun wind, until all that was left was the rocky core. Such is the unenviable past of Corot 7b and the no less terrifying present. We hope the rough conditions of that world didn't put you off, because we're moving on to the next planet. Although the next horrifying world doesn't have the same inferno-like conditions, it certainly fits into the category of places you never want to go near. Because trying to get to J1407b, you would come across an endless belt of rock and ice. It's tempting to compare this massive gas giant to our Saturn because it's surrounded by gigantic rings, except they're 200 times wider than the ones around Saturn. While Saturn only has 3 main rings, J1407b has 30 rings spanning across over 110 million miles. Now let that sink in. That's 20% more than the distance from Earth to the Sun, which is 93 million miles, which is 1.2 astronomical units. For comparison, the radius of Saturn's largest ring is only about 300,000 miles. Rings of this scale only form thanks to mass destruction of a planet's satellites. So what might have happened? It's likely that the mass of J1407b is between 10 and 40 times the mass of Jupiter. That's a huge celestial body, the gravity of which just ripped the satellites apart. There's another theory that J1407b is not a gas giant, but an actual protostar that was never able to become a brown dwarf. Currently, there's no consensus in the scientific community as to how to properly classify such objects. Another argument towards the theory that J1407b is an incomplete star is the fact that the object moves along its orbit around the host star as opposed to around the mutual center of gravity like happens with a dual star system. What's amazing is that these huge rings have a mass of only 7.34 by 10 to the 21 tons. Why only? This impressive number is comparable to Earth's mass, 5.9 by 10 to the 21. In the history of J1407b could have been many amazing and frightening events, and one of them could have been a collision with a satellite with the mass somewhere between Earth and Mars. The trace of this encounter, a large gap in the rings of J1407b. Speaking of which, thanks to these gaps, the scientists managed to discover this planet. Using the transit observation method, the scientists managed to find out not only the size, but also the position of the rings around the planet. Take a look at the visualization of the Saturn rings, a truly magnificent sight. We can only imagine what kind of view we could have if we were on J1407b or one of its satellites, but this view would definitely cost us a jaw because ours would be dropped. Now we're heading closer to home. About 80 light years from the Sun is an object that can be rightfully crowned as one of the loneliest in the universe. The interesting thing about the planet with a complex name, PSO J318.5-22, is that it doesn't revolve around a star. PSO J318 belongs to the special classification of planets called rogue planets, sometimes called orphans or nomads. These planets are ejected from their planetary system and now they just wander through endless emptiness of space. Paradoxically, the absence of a bright star only played into the hands of astronomers. They can directly observe the light of PSO J318 without it being overshadowed by the host star. Since the surveillance is performed using the PS1 Panoramic Survey Telescope pan-stars, the excess light really hinders observation from Earth. It allowed to take hundreds of infrared photographs, which reveal that the planet's 8 times larger than our Jupiter and much brighter too. The shifts in its brightness showed that the planet does a complete turn every 5 hours and has several layers of thick and thin clouds with a temperature around 1470 degrees Fahrenheit. Surveillance performed by a group of astronomers using New Technology Telescope at the European Southern Observatory in Chile allowed them to create one of the first somewhat accurate weather forecasts for a celestial body beyond the solar system. And now, a quick weather report. We're expecting a cloudy but very warm day with dust storms several times the speed of sound and possible precipitation in the form of molten iron rain. The estimated age of the planet? It's around 12 million years old. Scientists don't know exactly how such planets are formed, but they theorize that such objects were either unsuccessful stars, gas giants several times as large as Jupiter, or planets ejected from young planetary systems after encountering another planet and under the influence of its gravitational field. After being cut off from the gravitational influence, they don't return to their original system, doomed to drift through space until they're pulled into the gravitational field of another star system. As a result, there's an issue with classification of PSO J318 and similar planets because many scientists tend to refer to such objects as sub-brown dwarfs, hinting at their temporary state. Not yet a star, but not quite a planet, a gas giant either, at least as we know it. Although the scientists have records of quite a few rogue planets, this is only the beginning of their research. We're likely to be amazed. We're moving on to witness the slow merry-go-round of death, a place where we'll find WASP 12b, a planet labeled by scientists as doomed. Being on its planet's surface is impossible for a number of reasons, with the most significant one being that the planet's literally torn apart by its host star, piece by piece, sending it out into the outer space. According to its characteristics, WASP-12b is a gas giant with a radius about twice the size of Jupiter's. However, unlike Jupiter that performs one full revolution around the Sun in 12 Earth years, WASP-12b fully revolves around its host star in one day. Such speeds create unbelievable tidal forces on the surface of the planet, causing it to distort. If the scientists' calculations are accurate, WASP-12b is shaped more like an egg than a sphere. Astronomers estimate that the planet won't be able to withstand such torture much longer, a maximum of 10 million years, after which the planet will completely fall apart, forming a gas and dust cloud that will be gradually consumed by the star. Furthermore, the planet speeds up as it exchanges matter with its star. Until this moment, the scientists thought this type of exchange was only possible between stars. The case of WASP-12b is the first confirmed case of this phenomenon happening to an exoplanet. This gravitational dance really heats up the planet, making it reach temperatures up to 4,100 degrees Fahrenheit, making any possibility of life on its surface obsolete. But 5 years after the planet was discovered, the Hubble telescope managed to use the spectroscopy method to detect the signs of a water stream, an incredible discovery considering the conditions on this planet. The other shocking discovery is that the hard surface of this planet, if it indeed exists, can be made of graphite and diamonds. The reason for that's the high concentration and density of carbon in the composition of the planet. Some media outlets even nickname WASP-12b the Diamond Planet. But for now, scientists are more inclined to think the vast majority of the carbon is contained in the planet's atmosphere in the form of carbon monoxide and methane. Additionally, in 2012, research established that the planet may have a satellite, WASP-12b1. Its radius estimated to be 6.4 times the size of Earth's radius, which is only 3 times smaller than the radius of the planet itself. What kind of conditions are on the surface of the satellite, we can only guess. Probably not much better than its torn-apart neighbor. And the next planet is surrounded by real mystery. We're talking about Fomalhaut b, formerly known as Dagon, a distant world that didn't exist. Are you intrigued yet? Well, let's dig in. Let's go back to 2004. The Hubble telescope discovered a gigantic cold debris disk of gas and dust. Immediately, the theories about the object started circulating, including the estimation of the planet's size, which could be 3 times as large as Jupiter. Furthermore, the scientists still hadn't managed to get a look at the huge planet, which was supposed to rotate around Fomalhaut, one of the brightest stars in the night sky, located relatively nearby at 25 light-years away with a radius twice as large as the Sun. Research showed that Dagon was behaving in a very strange manner. The speed of the object kept increasing as time went by. 4 years later, in 2008, the news that an image of Dagon was captured causing a real sensation in the scientific community. It was proven that the planet is much smaller than estimated previously, with a mass somewhere between Earth and Mars. The dim glow of Dagon in the infrared range and its inability to affect the debris ring of the Fomalhaut star indicated a low mass. Additionally, the brightness of the object decreased while its size got bigger, and its orbital movement did not correspond to the predicted data. Scientists have reached an impasse. Astronomy has not yet encountered anything like this. In 2014, Dagon decided to finish the scientists off and just disappeared. Although in previous years the object was consistently registered, starting in 2008 the planet started increasing in size and becoming more dim until it was completely gone. All of these events went against everything the scientists knew about exoplanets. The researchers had to practically review the data again to come to a new, radical conclusion that the planet Dagon never existed. The new theory proposed by the scientists suggests that the object originally interpreted as an exoplanet was a slowly dissipating dust cloud that formed as a result of a massive collision between two asteroids or planet fetuses. This discovery is even more amazing because a collision between two small celestial bodies is incredibly rare. The collision must have happened back in 2004 when the Hubble telescope was surveying the area around Fomalhaut. Coincidence number 1. As time went by, the dust began to spread, which explains the increase of the object's size and the lowering brightness. Coincidence number 2. And the dust cloud that formed in the collision explained the eccentric orbit. Coincidence number 3. And so a string of incredible coincidences confused the astronomers and created a beautiful legend about a strange and unpredictable planet Dagon that does not look like a planet or move like a planet, does not revolve around a host star on an elliptic orbit like a planet, and instead moves along a runaway trajectory that eventually takes it far away from the star. Although Fomalhaut B lost its exoplanet status, it's no reason to be discouraged. There are thousands of known and confirmed exoworlds waiting for us, which are definitely going to surprise us with their terrifying yet incredible characteristics. And how
Guys, मेरी losing streak तो खत्म कराओ।
हम आ गए हैं जीतने के लिए। चलो 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 on your left, on your left। right करना।
And how about a journey to a planet that witnessed the first steps of our universe? The incredible world of Captain B is only 13 light years away from us, but its age is estimated at 11.5 billion years, which is about 2.5 times older than our Earth and only 2 billion years younger than the universe. But we're not just impressed by the age of this rock hurling through space, but also all the things that may have happened on the surface of the planet throughout its existence. The thing is, this planet's host star, Captain, is classed as a red subdwarf, and therefore it has an anomalous luminosity spectrum due to its age. The star radiates almost 250 times less light than our star and has a mass a quarter of the Sun's mass. As such, the scientists claim that the planet is within the habitable zone in relation to its star, even though it's very close, only 0.168 astronomical units, which is even closer than the distance between the Sun and Mercury. Now, theoretically, the temperature on its surface allows the water to retain its liquid form. By some estimation, the temperature varies between negative 58 degrees Fahrenheit or negative 50 centigrade on the dark side, and 50 degrees Fahrenheit or 10 degrees centigrade on the star-facing side. All of these parameters affect the ESI index, also known as the Earth Similarity Index. As of the release of this video, the ESI for Captain B is 0.67, similar to planets KOI 4005-01 and Kepler 62f. One of the main potential candidates for discovering extraterrestrial life forms. Of course, the age itself is not enough reason for life forms to appear, but it significantly increases the chances of it being habitable. The conception of life is a very long and complex process, and if 4.5 billion years was enough for life to develop to the point where you're watching this video right at this moment, then 11.5 billion years on Captain B might have been at least enough for microorganisms to develop. Perhaps, for many years there had been ancient life forms watching us closely. What do we know about black holes? It's a very dangerous object, an area of space-time with a gravitational pull so high that it absorbs everything in its vicinity, including light. For a long time, black holes have had a reputation of a space monster that consumes everything around it, and it can even destroy information. But how accurate are these accusations? What if we tell you that black holes can do more than destroy entire star systems? They can create them too. Let's take a closer look at their theories. For starters, let's talk about the terminology. Are these objects actually holes, and are they actually black? If you ask scientists from different scientific backgrounds the question about the nature of black holes, their answers may be similar, but the approach would be different for a physicist, an astronomer, a mathematician, for example. That's because within a black hole, the laws of physics
I'm Professor Rick Mitchell, and I teach pathology at Lecturio and also at Harvard Medical School. And I've seen the academic success and the stress relief that medical students have got using Lecturio Medical. So download the app now, see if it works for you, and I'll see you in class.
That's because within a black hole, the laws of physics as we know them doesn't function the same way. And according to Einstein, gravitation within this object warps space so much that it forms a tear. So how does a black hole form? Can it form in place of any star? Scientists are still debating about the mechanisms behind the appearance of black holes, but the most popular theory is the gravitational collapse, which suggests that the hole can only form from stars the mass of which is between 2.5 to 5.6 times larger than the Sun's mass. And yet once the black hole is formed, it will only be a few dozen miles in diameter. Incidentally, if the Sun ever became a black hole, its radius would only be 1.9 miles, whereas the original radius is around 430 2,450 miles. What is the significance of these numbers? What determines the compression limit at the point a star becomes a black hole? It's called the Schwarzschild radius, named after astronomer Karl Schwarzschild, who was the first one to discover this pattern. The thing is, any object in the universe can be turned into a black hole if it's compressed down to a certain radius. And the Sun would have to be compressed to 1.9 miles in radius. For Earth, that figure is 0.35 inches, just a little larger than a grain of rice or a ball in a ballpoint pen. You can use this formula and have fun calculating how much you'd need to compress the objects around you to make them into black holes. There are two you stumble upon a door, leading to an exactly the same room. In this case, the door is a real object in a specific location. It would be a different matter entirely if walking around in a dark room, you stumbled into a black hole. You would simply not notice the transition. There's no solid, physical boundary in front of a black hole. A black hole is a place where the mass has warped space-time, and as a result, no object can leave it once it crosses the boundary. Everything that entered the black hole will forever remain beyond the horizon. This is one of the fundamental questions occupying the minds of astronomers around the world. What's inside? What would an observer experience inside the black hole? And what would that look like to the outside observers? In the moment when you cross the event horizon, the reality would split into two parts. In one, you'd instantly evaporate from reality. In the other, you'd be frozen in place, safe and sound, before gradually disappearing forever. As we already mentioned, crossing the event horizon would happen completely unbeknownst to you. Think back to the dark room analogy. And what's amazing is that as you move closer and closer towards the gravitational singularity, you won't experience any turbulence, any pull or pressure. You'll simply be in a state of freefall. And if we're talking about your subjective perception, there will not be a horizon for you. We must say that this theory only applies to large-scale black holes, millions of times larger than the Sun, whereas in case of smaller black holes, you would experience a deathly discomfort. The gravitation would affect your body disproportionately, and you'd be stretched out like a strand of spaghetti. And by the way, that's the official scientific term for this process: spaghettification. But for the purpose of this experiment, let's imagine we found ourselves inside a fairly large black hole. We are doomed, but at the very least, we won't die instantly, making a relatively steady descent towards the singularity instead. And so you're calmly flying through the infinitely warped space, headed for the gravitational singularity, while the outside observers claim that you have vanished next to the black hole. Who's right in this case? According to physics, both. Additionally, according to Stephen Hawking's theory, you can slowly vanish within the black hole and be essentially erased from the universe, which leads to a serious paradox. In accordance with the laws of quantum physics, from the point of view of the observer, you cannot cross the event horizon. You must stay outside of the black hole. One of the fundamental laws of physics says that information cannot be destroyed. When you are inside the black hole, the physical you, the atoms your body is composed of, cease to exist. From the observer's point of view, this would go against the law of physics. Stephen Hawking determined that aside from everything else, black holes also evaporate. On the border of the event horizon, so-called virtual particles are formed. Although the probability is low, one particle can be devoured by the black hole, while another remains outside of it, turning into radiation. Hawking radiation. This way, a black hole can very slowly lose its mass. It would take 10 to the power of 100 years for a supermassive black hole, which is formed through the merging of several black holes, to evaporate. And in theory, any object that enters a black hole stops existing as we know it. All of its matter turns into heat, which goes against the principle of indestructible information. That's something known as the black hole information paradox. Fortunately, the scientists succeeded in getting closer to unraveling this paradox, but not without some caveats. According to research by students from the University of Ohio, black holes are actually gigantic fuzzy balls, or as they are literally christened in the study, fuzzballs. Contemporary theory suggests that a non-spinning, non-charged black hole is characterized by a single indicator, its mass. If an object enters the black hole, all of its characteristics and state at the time of the event will make no difference. All that will change as a result of this absorption is a mass increase. There is an expression to describe this aspect. Black holes have no hair. What it's trying to say is that all non-spinning and non-charging black holes of the same mass are indistinguishable from one another. Even if the information about the object is stored inside the black hole, it has no influence on its radiation. But string theory physicists found an elegant solution for this paradox. According to this theory, all matter surrounding us is made up from thin, vibrating quantum strings, and to understand the way they work, we should imagine the strings of musical instruments. Normal strings can vibrate, bend, fold. The same thing can happen to these quantum strings. And so according to theoretical physicists, black hole may look like a fuzzball created entirely from quantum strings vibrating in accordance with their special quantum laws. In this case, we can imagine a black hole not as a place full of densely packed particles, but as a yarn ball of quantum strings. In this theory, there's no singularity or even an inside of the hole. Space-time simply doesn't exist beyond the event horizon. Consequently, you as the object couldn't enter the black hole. Your fall would change the vibrations of the fuzzball, which would affect the radiation emitted by the black hole. As a result, the information is not destroyed. The fuzzball theory helped to resolve another paradox pertaining to the physics of black holes. We already mentioned Hawking radiation, but we didn't specify that the mechanism of this hypothetical radiation emanating from the black hole is linked to creating virtual particles in a vacuum. Generally, these particles can be observed in the same way we see light radiated by the sun and other high-temperature bodies. The difference between Hawking radiation and electromagnetic radiation from celestial bodies such as stars is that in the case of the latter, photons are generated from interacting elementary particles as opposed to from nothing. Photons emitted throughout the lifespan of a black hole will have an entropy too great for the process to correspond to the general principles of quantum mechanics. In a nutshell, entropy is a measure of how evenly the energy is distributed within the universe. The principles of quantum mechanics require for the photon entropy to be lower than the entropy of the black hole. To resolve this paradox, scientists considered a phenomenon known as the wormhole paradigm. To properly calculate entropy, you must account for the photons leaving the gravitational field of the black hole, as well as the particles that enter the black hole. If we view a black hole as a classic general relativity object, with an event horizon and a singularity, the equations have inconsistencies. However, if black holes are viewed as the string theory, fuzzballs, that problem is solved. And very recently, in January 2022, Old Man Hubble delivered another surprise related to black holes. Turns out the radiation we discussed can directly influence the process of forming stars, lighting up the stars in a faraway region of space as if in confirmation of the fuzzball theory. While observing the faraway galaxy Hines 2 to 10, Hubble discovered a flow of radiation moving towards a dense gas cocoon from somewhere around the center of the galaxy, presumably where a black hole must be. Spectroscopy showed that the radiation moved at the speed of around 1 million miles per hour, crashing into the dense gas formation and changing its density. This is opposite to the effect observed in larger galaxies. There, matter approaching a black hole is swept up by the surrounding magnetic fields, creating flaming bursts of plasma. These jets move at a speed close to the speed of light. Any gas clouds that get in the way of these jets emitted by a black hole would be too hot, limiting their ability to cool down and form a star. The matter will simply be unable to condense into a star. With the less massive black hole at the center of Heinz 2 to 10 and the softer radiation it emits, gas was compressed just enough to start the process of forming a star. Heinz 2 to 10 is only 30 million light years away, close enough for the Hubble telescope to record images and spectroscopic evidence of black hole radiation. Scientists expect that in the future, even more research will be dedicated to studying black holes in such dwarf galaxies. This could become a key to uncovering a mystery of the origins of supermassive black holes in the early universe. The main clue may have something to do with the mass of a galaxy and a black hole at its center. This type of research once again brings up the undeservedly tarnished reputation of black holes. Turns out, as well as consuming, they can also create. And this is yet another reason to take a fresh look at black holes, not as some scary monsters hiding in the depths of space, but as incredible, unique objects that turn our understanding of space upside down. Multiverse theory is no longer just a part of a good sci-fi story. There are now some scientific theories that support the idea of a parallel universe beyond our own. However, the multiverse theory remains one of the most controversial theories in science. Today we'll find out where the edge of our universe lies, if the multiverse really exists, or if it's just a philosophical concept. Let's take a closer look. Let's start from the beginning. No, the very beginning.
Guys, मेरी losing streak तो खत्म कराओ.
Yes, here, right here, where at some point our universe was born. So where is here? The question is irrelevant because space as we know it does not yet exist. All matter, all that exists, time and space, absolutely everything that has ever existed and still exists was here in one spot. This spot is what we call the singularity. And then the singularity rapidly grew much larger. The Big Bang had occurred. Stop. Let's take a look at the time. By the way, yes, it already exists. And so 10 to the minus 43, perfect. We are in the Planck epoch. Here, we'll draw the line of before and after. We have absolutely no idea about the events, phenomena, and laws of nature before this moment. The singularity remains the most mysterious and unexplained state of the universe for us. All of our theories and formulas stop working. Stephen Hawking explained it as, the results of our observations confirm the hypothesis that the universe occurred at a particular moment in time. However, the actual moment of creation, singularity, does not obey any of the known laws of physics. The singularity appears to be a paradox. In theory, it should have infinite density and temperature, which is impossible in practice because with infinite density, the entropy is approaching zero, which is not consistent with infinite temperature. There are many paradoxes like this one. Let's get back to the Planck epoch. Why is it called this? It took place during the Planck time, the minimum measurable or detectable time span in our universe, from time 0 to 10 to the minus 43 seconds. In this epoch, the fundamental forces of physics, electromagnetic, weak and strong interactions, were combined, kind of like a unified superforce, a super interaction between matter. Due to extreme conditions, this system was unstable, and the unity of force and matter came to an end. The process we call matter asymmetry or baryon asymmetry practically created the physical conditions, constants, and particles that we observe to this day. From our perspective, this fact is unusual to modern physicists because neither the standard model of particle physics nor the theory of general relativity provides a known explanation for why this should be so. What's strange is that physicists predict the Big Bang should have produced equal amounts of matter and antimatter. But in fact, we practically do not see antimatter anywhere. What occurred was the definitive divide into matter and antimatter. Matter became the dominant form of substance in the universe. The disruption of symmetry led to the second stage of creation, the so-called grand unification epoch. At that time, gravitation finally becomes a separate force. The three others are still unified as the electro-strong force. The universe became relatively less homogeneous. There is a shift in its density. The second stage, the grand unification epoch, ends as quickly as it started, around 10 to the minus 36, from the moment of the universe's creation. Next, the combination of various factors led to rapid expansion of the universe. In an instant, a spot the size of a subatomic particle expanded to the size of an orange, and another moment later, to the size of a galaxy. It continued to grow exponentially during the rapid expansion of the universe. Some points in the universe were moving apart faster than the speed of light. This is an apparent contradiction because to emerge is not permitted to propagate through space faster than the speed of light from the perspective of any other observer in the universe. However, according to scientists, this contradiction is resolved because while the distance between objects is increasing faster than the speed of light, the objects are not moving through space faster than the speed of light. It is, in fact, that more new space is being created in between them. From now on, we will forego a few more epochs of the universe's creation to get back to the main topic of this video. Let's just establish the fact that our universe has a volume, it's homogeneous and relatively cold. The matter that prevails here is familiar to us, and this is practically the universe in which you and I live, except there are no stars and planets yet. But what shape is it? In order